Hello, welcome to another aspect of A-level physics. Today we'll be talking about very fascinating aspects of physics, and that is radioactive decay. We are going to delve into details to look at some important areas of it. And at this topic, we'll be looking at stable and unstable nuclei. We also look at the types of radioactive decay. Then we proceed to look at some of the recent advancements in radioactive decay and some interesting inventions under this area of physics. Then we also talk about everyday applications of radioactive decay. So, what do we mean by radioactive decay? Radioactive decay is simply defined as the spontaneous disintegration of unstable atomic nuclei with emission of alpha, beta, and gamma particles, which also is accompanied by large release of energy. Let's proceed by understanding what we mean by stable and unstable nuclei. For us to know whether a nuclei is stable or unstable, we need to determine the proton to neutron ratio of that particular nuclei. Now, when you determine the proton to neutron ratio and you get a value that is less than 1.6, then it means that atomic nuclei is stable. Conversely, if you determine the proton to neutron ratio and you get a value that is greater than 1.6, then it means that nuclei is unstable, and that means it will undergo radioactivity at any time. What are the types of radioactive decay? We have alpha decay, we also have beta decay, and the last we talk about is the gamma decay. Now, let's look at alpha decay. Alpha decay occurs when a radioactive nuclei emits alpha particle. This results in reduction of the atomic number by 2 and also reduction in the mass number by 4. For instance, uranium-238 undergo alpha decay to produce thorium-234. And this has been applied in development of nuclear reactors and also nuclear weapons. Now, let's also look at beta decay. Beta decay occurs when neutron changes into a proton and emits an electron. Now, this results in an increase in the atomic number by 1, but the mass number remains the same. You can give an example of carbon-14 decaying to form neutron-14. Now, gamma decay occurs when the nucleus releases excess energy as a gamma ray. Now, what happens to the atomic number and the mass number? Here, we don't expect any change in the atomic and then the nuclear number. That means our atomic number and the mass number is going to remain the same. Now, at this point, let's also look at some of the recent advancements in radioactive decay. Now, do you know there is going to be more advanced alternative to atomic nuclei? Okay, physicists are getting nearer to constructing the most precise and accurate clock, which is known as nuclear clock, and they are using the nucleus of thorium-229 in this invention. These nuclear clocks could be used for deep space travel, GPS systems, and even to test the laws of physics more precisely than atomic clocks. So you can see how effective and applicable radioactive decay concepts are helping in invention of more advanced clocks that can help in our astronomy and also in a precise verification of some of the physics concepts and laws that we have. Well, another recent development is smoke detector. Yes, physicists have moved on in more advanced device that can help us to detect smoke in our various homes and offices. And this device is being manufactured by use of americium 241 in its operation. Now, this americium 241 is man-made radioactive element, and it is being used by physicists in manufacturing of this vital smoke detector device. Now, let me take a few seconds to explain how this device operates. Now, alpha particle in the chamber ionizes the air, creating positive and negative charges. And these charges flows continuously by creating current to power the device. Now, when there is a smoke or when smoke enters the device, the smoke knocks out some of these charges, reducing the current that is flowing in the device. Now, this triggers the device and the alarm will eventually sound for us to know there is a smoke in the room. That could be a fire outbreak. Let me go back by summarizing what we have done so far. Today, we have looked at radioactive decay. We have defined radioactive decay as the spontaneous disintegration of unstable atomic nuclei, which emits alpha particle, beta particle, and gamma particle with emission of enormous amount of energy. We have also talked about the types of radioactive decay. We talked about alpha decay, beta decay, and gamma decay. We have also looked at some advancements in radioactive decay in our world of science. Some other applications that we talk about in our next lesson will be some of the application of radioactive decay in our medicine, industry, and even archaeological dating. Thanks for your time and your cooperation. Stay tuned.